Welcome to the tutorial room. Select a topic. Chapter 8, Introduction to Section 8.8, Using Equivalent Equations to Solve Linear Equations. In this section, you'll learn the definitions of equivalent equations and the rules for making them. We'll also teach you how to use simpler and simpler equivalent equations to solve linear equations in one variable. Two equations are equivalent if they have the same solution set. Making equivalent equations is easy if we follow these simple rules. We can add or subtract the same variables or constants from both sides. Multiply or divide both sides by the same non-zero real number. We cannot perform an operation on just one side of the equation. Multiply or divide the equation by a variable. Raise a variable to a power. To solve an equation, we replace the original equation with simpler and simpler equivalent equations until the variable with a coefficient of 1 is isolated on one side of the equation. A constant is on the other side. Here are the steps for making equivalent equations. 1. If the equation has fractions, multiply each term on both sides of the equation by the least common denominator to eliminate the denominators. 2. If the equation has parentheses, use the distributive property to clear the parentheses, then combine like terms and constants. 3. Add and subtract terms until the variables are on one side of the equation and the constants are on the other. Then combine like terms and constants, so one side of the equation now contains a single term with a variable. The other side of the equation contains a single constant. The variable with a coefficient of 1 is now isolated on one side of the equation. The other side is a constant. 5. To check the result, substitute the root we found into the original equation and verify both sides are equal. Example 8.8.1. Solve the equation 2x plus 8 equals 14. This equation doesn't contain fractions or parentheses, so start by getting terms with variables on one side and constants on the other. Since the variable x is on the left side, we will first eliminate the 8 and then the 2, so that only the variable x remains on the left side of the equal sign, and the solution is on the right side of the equal sign. You can also think of adding and subtracting terms as moving the term to the other side of the equation and changing the sign. To check the result, substitute 3 in the original equation. Since 14 equals 14, 3 is the solution for the equation. There are no other values which satisfy this equation. Example 8.8.2. Solve the equation 6y minus 15 equals 2y plus 9. This equation doesn't contain fractions or parentheses, so start by getting terms with variables on one side and constants on the other. You can also think of adding and subtracting terms as moving the term to the other side of the equation and changing the sign. To check the result, substitute 6 for y in the original equation. Since 21 equals 21, 6 is the solution for the equation. There are no other values which satisfy this equation. Example 8.8.3. Solve the equation t over 6 plus 2 equals t over 3. Since this equation contains fractions, we have to multiply by the least common denominator to clear the fractions. The least common denominator of t over 6 and t over 3 is 6. To check the result, substitute 12 for t in the original equation. Since 4 equals 4, 12 is the solution for the equation. There are no other values which satisfy this equation. Example 8.8.4. Solve the equation 4 times s plus 1 equals negative 2 times 4 minus s. Since this equation contains parentheses, start by using the distributive property to clear the parentheses. To check the result, substitute negative 6 for s in the original equation. Since negative 20 equals negative 20, negative 6 is the solution for the equation. There are no other values which satisfy this equation. Here, try these practices. Excellent job! Yes, you are right. Good job, you're right.